Okay, guys, let's begin. So we have already questions on our chat. The first one, show work 3, show work 4 from 2022.
Bakom voor de часто.
Okay. So we have to calculate this integral. So first thing that we can say, this is an integral of rational function. So we should treat it as integral rational functions, meaning that we should begin with checking whether here we have to begin with a long division or not. In this case, no need to do any long division because the degree of our numerator is 2, degree of denominator is 3. Okay. Next thing that we should try to do is to do factorization of our denominator. X squared plus 4x plus 5. Can we find roots of this polynomial? What do you think?
No, we can't.
Yeah, it's an irreducible quadratic form. Discriminant here is negative. So we can do here decomposition. So we can split into two terms, a divided by x minus 1 and plus the second term, which has x squared plus 4x plus 5 denumerator, which is second order polynomial, meaning that we have to consider bx plus c first order polynomial as our numerator. Okay, so after this, we have to find these coefficients a, b, c, and then we'll try to integrate these two integrals. So bringing the common denominator, a will be multiplied with x squared plus 4x plus 5 plus x minus 1 multiplied with bx plus c, which should be equal to x squared plus 8x plus 11. Okay. And now how we can calculate a, b, and c. Either open all brackets and coefficient of x squared should be 1, coefficient of x 8, and the constant 11, or plug 3 values for x and get 3 equations for a, b, and c. I don't think there is a big difference between these two methods. Let's plug x equals to 1. We'll get 1 plus 4 plus 5, 10a equals to 1 plus 8 plus 11, 20. So our a is 2. Then we have to plug 2 other values. There is not any obvious option for x, but just do 0 and maybe 2 or any other constant. Plugging 0 will get 5 times a, 10, minus, so when x equals 0, here we get minus 1, minus c equals to 11. So our c is minus 1. And to find b, I don't know, we can think about the coefficient of x squared. So coefficient of x squared here is a plus b should be 1, right? So a plus b equals to 1 implies that b is also minus 1. And having these values, we can now move to the integration. Our a is 2, so the first integral a divided by x minus 1 dx plus the second one. Second integral is bx plus c, so x plus 1 with minus sign. I put it minus up front, divided by x squared plus 4x plus 5 dx. So we should calculate these two integrals. I would begin with the second one. The first one, I will leave you an exercise. How one can integrate x plus 1 divided by x squared plus 4x plus 5. Here, the trick is completing square. So we have to integrate x plus 1 divided by, if we complete square, we'll get x plus 2 squared plus 1 dx. So the integral can be split into two parts, x plus 2 divided by x plus 2 squared plus 1 dx, and plus another integral minus 1 divided by x plus 2 squared plus 1 dx. If you wish, guys, before this split, you can do x plus 2 equals to use substitution. It's fine also. So the first integral, we can do use substitution. Here, x plus 2 squared plus 1, if we denote by u, immediately we will get, so if this is our substitution, 2 times x plus 2 dx is going to be our du. We have x plus 2 terms, 2 is missing, so 1/2 du divided by u, which is 1/2 logarithm module u, or just x plus 2 squared plus 1. And the second integral we can calculate by, again, maybe doing x plus 2 equals to u substitution. Or if we do x plus 2 equals to u substitution, it will be immediately transformed into 1 over u squared plus 1 du, which is arc tangent. So it will be arc tangent x plus 2 plus c here plus c1, c2 here. Questions? No question means we can move forward. And the next exercise was this one, third one. So calculate this limit as x goes to infinity. We can try first to see limits of each of component here. When x goes to infinity, inside of bracket we have plus infinity. And what is the limit of power? Guys?
It tends to 0, no?
Right. So we have plus infinity to the power of 0. What is plus infinity to the power of 0? it's an indeterminate form, meaning that we have to calculate this limit applying some technique, maybe L'Hopital rule, but we do not have L'Hopital rule for infinity to the power of 0 form. We can transform it into that form, or another trick here can be applied. For example, so the fastest way to calculate this limit is take exponential x into common. So we will get e to the power of x multiplied with 5 plus 3x divided by exponential x to the power of 1 divided by 2x minus 5. So this can be written as e to the power of x divided by 2x minus 5 times 5 plus 3x divided by exponential x to the power of 1 over 2x minus 5. So when x goes to plus infinity, let's just focus on this part. So what we can say about this limit. When x goes to infinity, what is the limit of 3x over exponential x?
0.
0. So we get 5 plus 0 to the power of 0. What is 5 to the power of 0?
1.
Correct. And what can we say about the other term that we have here? What is the limit of power when x goes to plus infinity? What is the limit of x over 2x plus 2x minus 5?
0.
1 over 2.
1 over
Oh,
2.
1 over 2. Yeah.
1 over 2. So we get just e to the power 1 over 2. Combining these two together, we will get that limit is root of e.
Can you please show how you would do it with L'Hopital?
Yes, sure. So with L'Hopital rule, we can calculate this limit in the following way. So the main idea is that any number function a can be written as e to the power of logarithm a, right? So instead of finding the limit of 5 times exponential x plus 3x taken to some power 1 over 2x minus 5, which is our a. So instead of finding this limit of a, we can say, let's write it as a to the power of logarithm of 5 multiplied with exponential x plus 3 times x to the power of 1 over 2x minus 5. And the property of logarithm, that power can come in on front as multiplier, we'll get here nothing else than just e to the power of 1 divided by 2x minus 5 multiplied with the logarithm function, 5 exponential x plus 3 times x. And now we can consider just limit of our power. At the end, we will consider e to that corresponding power. Okay? And here we have ratio. Finally, we have a ratio. Let's calculate the limit of this ratio separately, and we will come back to complete the exercise. So what is the limit of x when x goes to infinity? Logarithm 5 times exponential x plus 3 times x divided by 2x minus 5. So let's calculate the limit of this part. We have, when x goes to infinity, it's infinity over infinity. Meaning we can apply L'Hopital rule. And L'Hopital says that we can consider just limit of the derivative of our numerator divided by the derivative of the denominator. What is the derivative of our numerator? Derivative of logarithm gives 1 divided by 5 times exponential x plus 3x. Chain rule says we have to multiply with derivative of denominator and derivative of this term. So derivative is 5 times exponential x plus 3. And we have here derivative of denominator just 2. So after just shuffling a bit, we'll get limit x goes to plus infinity, 5 exponential x plus 3 divided by 10 exponential x plus 6x, which is limit. You can divide numerator denominator by exponential x, and immediately we will get 5 plus 3 over exponential x divided by 10 plus 6x over exponential x. And as x goes plus infinity, 3 over exponential x goes to 0. X over exponential x goes to 0. It remains 1/2. So going back, we can say limit is e to the power of 1/2. Okay.
Thank you.
Let's move forward, and we have another question from the same test. Question. Second multiple choice. Okay. Given a table from which we can learn values of function f and f prime, and then another function h is given, we should, from this table, find true statements. So the first statement is about h being increasing from 2 to 4. Guys, can we say function f is increasing? Look, 3, 4, 9, 13. Can we say f is increasing?
No.
No, we can't. Just knowing 4 values, we can't say that function f is increasing. Hence, we do not have enough information to say that age also is increasing. No enough information, so this is not correct. So we can say that the answer can't be true. So let's eliminate it. And then it remains second and third. Second statement says there exists C from 0 to 4 such that HC equals to 12. So to justify this, maybe an intermediate value theorem was implied. So let's check whether we can apply intermediate value theorem here. To do it, we need to understand what is h0, and we need to understand what is the value of h at 4. h0 is f0. So just 3. h4 is f8. And what is f8 is 13. Since our function f is differentiable, it is continuous also. Continuous function at 0 is 3, at 4 is 13. The intermediate value theorem says there exists at least one point C from 0 to 4, where value of our function is 12. Hence, we can say for sure statement number 2 is correct. What about number 3? Is statement number 3 also true or not? So number 3 statement is a bit different. It is about the derivative of our function. So now we have something similar to mean value theorem. And if we think of mean value theorem for the interval 2 to 0, h2 minus h0 divided by 2 equals to h prime at some point c. What is h2? h2 is f4. F at 4 is 9. So we get 9 minus 3, h0 is 3, divided by 2 equals to h prime at some point c. Which means that third statement also is true. So second and 3 only are correct statements here. It's true. Questions?
Բան ներսան երկրորդը խի է ճիշտ։
Երկրորդը by intermediate value theorem. Intermediate value theorem says if you have continuous function which value at 0 equals to 3, value at 4 equals to 13, then in between for sure it has at least 1 0.
Բայց այդ I-ից ինչ էր ասում, որ F-ը անգամ
Not
F-ին
0.
փոքր է։
Sorry, not 0. It can take any value in between 4 and 13. In particularly for 12. So any constant from 3 to 13 is achievable by our function. So there exists C such that value of our function equals to 4, equals to pi, equals to 12.72. Any value from 3 to 13 is achievable by our function, in particular 12.
Լավ, մերսի։
Okay. So we had more question about this test, 2 and 3, I believe. This one also was a question. Given table here, we have to find, and we know the function is differentiable. What is the value of derivative of inverse function at 1? So first of all, do we know that function f is invertible? How we can justify that function is invertible?
It's decreasing, so it's 1 to 1.
Exactly. Monotonic function is invertible. Correct. What do we know about derivative of an inverse function? Our formula says it's 1 over f prime at some point x0. So we have to find this x0 and plug that value back into this formula. What is x0? x0 is a constant such that fx0 equals to 1. fx0 equals to 1, hence x0 is 9. So we have derivative of function equals to 1 divided by minus 5. So here is our correct answer. Okay.
I have a question.
Yes, please.
Why should we check is it invertible or not?
Just because I asked that. In this exercise, there is no such question. So just I asked why it is invertible. Because we have here some f minus 1 and just question whether function is invertible or not. To solve this exercise, there is no such requirement. Okay. The third. Okay. let me see. Do we have other questions from this test? Three, 4, 5, 7, 9. Okay. Third, which of the following statements is true? If f prime equals to 0, then f has local maximum or minimum at point C. Guys, is this statement correct?
No.
It's not, because what we can say if derivative at C equals to 0? What is the conclusion from f prime C equals to 0?
Yeah, critical point.
Right, critical point is not the same as extrema point. So we can eliminate statement A. Okay, let's do it. So A is not correct. F has absolute maximum value at C, then f prime C equals to 0. Is this correct or not? So we say C is a global maximum or absolute maximum, then derivative equals to 0. What
No.
do you think? Is this correct?
Օրինակ սա իր կետերում կարա լինի։
Exactly. We might have a case when global maximum is at endpoint, but derivative is not 0 at endpoint. Right, so let's eliminate this as well. What else? The third point, double derivative equals to 0. Then C is an inflection point. It's quite similar to the first question, right? So we can't say that this is true. So let's drop it as well. If f is differentiable, f minus 1 equals to f1, then there exists C, module C smaller than 1, such that f prime C equals to 0. What do you think? Is this correct? And why it is correct?
We can imply mean value theorem.
In particular, actually, yeah, mean value theorem immediately will conclude, but the case of mean value theorem when f minus 1 equals to f1, we are calling Rolle theorem. So it's just Rolle theorem. And let's see why statement E is wrong. Just because f prime equals to g prime, can we say the function is there? No. We can say fx minus gx is constant, right? Because derivative of f minus g equals to 0. But if derivative equals to 0, it doesn't mean that that is 0. It can be any constant. We can say fx equals to gx plus some constant c, but not necessarily that constant c should be 0. So this is also wrong. Okay, so we can just move forward. Okay. 3, 4, 5, 7, and 9. Fifth one. Xn be divergent sequence, Yn is convergent. We should find correct statement, which is true always. Like, Xn minus x2n is convergent. There is no any reason to say that xn minus x2n should be convergent. Xn is divergent. What if xn is divergent, x2n is convergent? We might have such case. Minus 1 to the power of n is a similar stop. Not true. Xn squared plus 3yn squared convergent. This one is convergent, correct. But adding xn squared, there's no guarantee that xn squared will be convergent. So let's drop this as well. 3xn plus y3n squared is convergent. This seems to be correct because y3n is convergent. This one is convergent. And convergent plus divergent is divergent. So let's circle this, but let's discuss the other two options. Hopefully they will be wrong. Xn squared plus yn convergent. No, because yn squared still might be divergent. Drop this. Xn squared plus yn is divergent, so it is similar to C. But what is the main difference? We know that 3 times xn is divergent. That's for sure, which we can't say about xn squared. Maybe this could be convergent, right? So we can't say that for sure xn squared is divergent. So it might be case when E also is wrong. Minus 1 to the power of n, xn squared is convergent. So it remains C, the only one that for sure is true. Next one, 7. GH be differentiable functions. F is defined G for negative x's and H for non-negative x's. Which of the following is true? Okay. So if G0 equals to H0, then F is continuous. Is this true? So what is continuity means here? What's the definition of continuity? Actually, a function is continuous if limit of f at 0 from both sides are equal. So 0 plus and 0 minus. So here, this part from right side, we have h of x. And since function h is differentiable, it is continuous. So we can say this limit is nothing else than h0. The same from this part. Left side, our function f is defined as gx, and the limit of g equals to the value of g because g is continuous. Why g is continuous? Because it's differentiable. And if we know that h0 equals to g0, so we have continuity. It seems we found the correct answer. But let's discuss the remaining ones. F prime 0 equals to h prime 0. Can we say f is differentiable? No, we can't. We can't because maybe function f even is not continuous. Maybe h0 is different from g0. Imagine the following case. Gx is constant 5 and hx is constant -1. This function definitely at 0 is not continuous, neither differentiable, but g prime equals to h prime because both have the same derivative, 0. If g and h are increasing, then f is increasing. No. What if this is our function increasing g? Yes. And here we have some open. Something like this. Both are increasing, but together function f is not increasing because this value is smaller than this one. G and h are concave up, then f itself is a concave up function. Again, no. Concave up here, just the open arm. And concave up here. Together it is not concave up. Why this two curves together is not a concave up function, what says the definition of concave up? Just link these 2 points. Can we say in between function is below of this line? Nope. In this region, it is not smaller. Sorry. So it remains A. And number 9. If I'm correct, the next one was number 9. Yep. FGH are function defined on R. F is an increasing function, G decreasing, H concave up. Which of the following statements is true? Okay. What can we say about the composition of F and G? Is it increasing or not? F itself is increasing, G is decreasing. What can we say about FGX? So is it increasing or not? To understand whether it is increasing function or not, we should choose x1 and compare the value of this function with FGX2, where we know that x1 is smaller than x2. If here the sign will be smaller, function is increasing. So what do we know about G? G is decreasing. G decreasing means Gx1 is greater than Gx2. And bigger or equal, maybe there's no any information about whether it's strictly decreasing or not. Love. If Gx1 is greater than Gx2, then function f is increasing. Hence, here the value should be greater than f Gx2, right? Because f is increasing itself. Fx1 here and 2 here. X2 greater than x1, but value of composition is smaller, so composition function is decreasing, not increasing. Let's check G as well, and then we will turn to concavity. What can we say about G composition with G? So we know this is true. So applying G again, we can say GGX1 is smaller or equal than GGX2. Okay, why so? Because if argument is smaller, then value is greater because function is decreasing. And this part means that our function is increasing because x2 greater than x1 implies GG at x2 is greater than GG at x1. Hence, increasing is the correct answer. Okay, next questions are about concavity. And actually, we can't say anything about concavity of, for example, F composition with F. From the beginning, we can drop because no any information about concavity of F. Just increasing is not enough. What can we say about concavity of F and F composition with H? Think of this being like differentiable function. And to check whether it is concave up or concave down, we can calculate derivatives. So first order derivative is f prime hx times h prime. So second order derivative, fhx double derivative gives f double derivative at hx times h prime x squared plus f prime hx times h double derivative x. Okay, double derivative is for h is positive and f is increasing. So this part, okay, is positive or non-negative. but we don't know anything about f double prime. F double prime could be positive, could be negative. So F composition with H, the same with G coming with H, there's not enough information given. None of this will be true, so it remains just E. Questions? Okay. So from this year, what do we have else? This is test
Ali,
122. Yes, please.
եթե concave up composition concave up-ը դրանից ինչ որ բան կարող ենք ասենք concavity վերաբերյալ։
Ստուգենք. So concave up composition with concave up function. So in this case, H composition with H composition with Hx. Let's consider this being differentiable function. What is the derivative? It's H prime Hx times H prime x. Hence the second order derivative. If I can, you mean in general H composition with F? Okay, yeah, it's much more general question, not H with H itself. Let me change a bit. So we have two concave up functions, H and F. Both are concave up. Can we say their composition is still concave up? Let's check. So we get H prime f of x times f prime x. So double derivative will be H double derivative f of x times f prime x squared. This term is positive, that's fine. What can we say about the next term? H prime fx, when we are taking derivative of this part, will be f double derivative x. So here, this is positive, okay, fine. But we don't know anything about H prime. And here we might have a case when, imagine H function is decreasing with concave up. Decreasing function, but concave up, something like this. It could be a case when composition function is not concave up. We can try to construct such example, maybe. But it's not so trivial. It's not so trivial.
Merci.
So once again, because H prime F could be negative. Okay. What do we have from this test? So 3, 4, 5, 7. Yeah, and show work number 4, maybe. This one. Given function module x squared minus 4x times sinus x, we should check whether this function is differentiable at 0, at 4, or not. To study differentiability of this function, maybe it will be easier to rewrite this function as, so here we have x times x minus 4, right? So we have here whether two cases, x belongs to interval from 0 to 4 or not. If it is in between 0 and 4, x times x minus 4 is positive, and our function will be x squared minus 4x times sinus x. And when x belongs to minus infinity to 0, and from 4 to plus infinity, our function is negative x squared minus 4x sinus x. And to check whether function is differentiable, for instance, at 0, to check whether function is differentiable at 0, we can consider two-sided limits. X goes to 0 from right side. We have to write f of x minus f0 divided by x. And on the right side of 0, we will get this function. Limit x goes to 0 from right side, x squared minus 4x. Value of function is 0, so we are going to divide by x. What is this limit, guys? X goes to 0 from right side. It is just x minus 4. Minus 4. And considering limit from the left side, f of x minus f0 divided by x. Sorry, guys, I missed sinus x term, which is very important here. Fortunately, I can just do Control Z, which you can't do during the final exam. Times sinus x, and its limit x goes to 0, x minus 4 times sinus x, which is what? Minus 4 times 0. Limit x goes to 0 from the left side. F of x minus f0 divided by x is going to be very similar limit with minus multiplier. X squared minus 4x times sinus x divided by x, which is again 0. So the conclusion is that f is differentiable at 0. So f is differentiable at x 0 equals to 0. Now let's check whether this function is differentiable at 4 or not. So we should adopt our previous proof by considering limit at point 4. Okay, let's see what do we get. Limit at 4. So 4 right side, 4 left side. 4 right side. At point 4, still value of our function is 0. f4 is again 0. So again, we have x minus 4 times sinus x, but now limit is not 0, but limit is sorry, we have here x minus 4. We have here x minus 4. So let me erase. Let me clean this up. And we get here limit x goes to 4 from the right side. We get x multiplied with sinus x, and this limit is 4 sinus 4. Doing similar calculation from the left side, we will get limit fx minus f4, and f4 is again 0. And here, dividing by x minus 4, we'll get minus 4 sinus 4. These two constants are different from each other, and as a conclusion, we can say our function is not differentiable at 0. At 4, sorry, at 4. No? Okay. Do we have other questions from this test? This is once again past final exam from 2022.
Can I ask one question?
Please go ahead.
When you wrote that x squared minus 4x where when x belongs to minus infinity to 0 and 4 to plus infinity, doesn't our x have plus sign here, our absolute value?
From minus infinity to, for example, when x is from minus infinity to 0,
When we're opening,
I see.
don't we need to write? Yeah.
Yeah, it's the same. Yeah, everything is yeah. What you say, shouldn't we? Yeah, like this.
Yeah.
Yeah,
And in the first part with minus.
you're right.
Yeah,
Minus
but
is
the answer will be the same.
the same. Yeah.
Yeah.
Minus. Yeah. Just we should change the sign of minus from 0 to 4. Of course, from between 0 and 4, our function is. We have something like this. This is 0. This is 4. It's negative in between 0 and 4, and before 0 positive. After 4 is positive. You're right. Thank you for correcting me. So minus is here, not above. Technically, yeah, it's not going to change any conclusion here that we made, but thank you for fixing this.
When did we need to check whether the value of the function was equal to the limits, if the limits were equal?
If the question is about continuity, then we have to check whether the limit equals to the value. In this case, the question is differentiability of our function. We have just to consider limit of fx minus fx0 divided x minus x0.
Okay, thanks.
Okay. Yeah, and we have also multiple choice number 5 from this test. Yeah, which we have discussed. So 2022 done. Let's
Orangs David uterort multiple learning.
sure. Okay. We are given function f equals x cubed minus 9x squared plus 24x, and our domain is from 0 to 4 closed interval. What is the supremum of the image of a through function f? Okay, so we have to find supremum fa. To do it, we need first to understand what is fa and then finding supremum. Our naive approach would be the supremum is f4, but not necessarily this will be true. Finding supremum, guys, of the image, it is the same as to find global maximum value of our function. We can just find global maximum value of our function. To do it, we have to calculate f prime x. F prime x gives 3x squared minus 18x plus 24, which is the same as 3 times x squared, so x squared minus 6x plus 8. Find roots of this polynomial. 36 so here we are going to get 2 roots. What is the discriminant? Discriminant here is 4. So our roots are 6 plus minus 2 over 2. 6. So 4 and 2, am I right?
Yes.
2 and 4. Okay, and we have given interval from 0 to 4. On this interval, what do we have? The derivative here is negative, here is positive. Increasing, decreasing. Hence, immediately we can say global maximum value of this is f at 2. This is global maximum point, and f2 is global maximum value, which is 8 minus 9 times 4 plus 48, 20. So supreme of image is the same as maximum value of our function, global maximum. So we did it. Questions? No. Any question? Let me switch the test. Let's discuss 2021. We have multiple choice number 1, 3, 4, 5, 6, 7. 2021. Okay. Okay. So once again, the questions are from 2021. First multiple choice question. F0 equals to 0, limit from right and left are given, 1 and 2. Which of the following function has a jump discontinuity? Jump discontinuity means that we have limit at point 0 from right, we have limit from left, but these are two different limits. Okay, so let's begin with the first one. When x goes to 1, x goes to 0, what is the limit of this from right and left? From plus side, we will get 1 over 1 squared minus 1 is going to be infinity. So this goes to, let's say, just infinity as x goes to 0 from the left side, because f goes to 1. If limit from one side is infinity, directly we can say this can't be a function with jump discontinuity because it has already essential discontinuity. So drop this one. The same with b. When x goes to 1, we have 1 over 0 infinity. It has essential discontinuity. C also is not possible because of this part. Limit from right side is 1 over 0. This is interesting one. We can consider it. Limit from negative part is 1 over 1 minus 3. Limit from positive part is 1 over 2 minus 3. So we have two different limits. Hence, we can say it has jump discontinuity. And why E is wrong? Because when we consider limit from right side, when x goes to 0 from right side, this also will be 1 over 0. So infinity. Hence, it has essential discontinuity. The only one that has jump discontinuity is D. Now, okay. Let me go to the first question. F continuous function, and we know that it has the following values. Okay. F at -10 is 1. So if this is -10, value is 1. At -8, it decreases to -2. At -5, it is still -2. And then at -1, it jumps to 2. At 0, it is 0. At 4, it is 2 again. So we have a curve that passes through these points. Our goal is to find at least how many critical points do we have here. Okay, to answer this question, let's connect all these dots by a smoothing way that possible. Something like this. And then our function, let's assume, is continues to increase. How many critical points do we have? This is a critical point. 1, 2, 3. So we can say we have at least 3 critical points. I can't do any better in this graph. Sorry, my drawing skills using this tablet is not perfect or close to the perfect. Here, it's everything smooth. So we have first put it dots, and then we try to connect these dots through some smooth curve. And then we are calculating the number of critical points. Okay. The next second one. Find all values of parameter A such that fx equals to ax squared plus 3x plus 4 at point x0. Yeah, so the tangent line is this. Okay. How we can tackle this question? Tangent line has the equation f prime 0 times x plus f0. And we are given that it should be 3x plus 4. What is f prime at 0? If this is our function f prime at 0 is going to be 3, because derivative of the first term gives 2 times ax. At 0 it is 0 plus 3. Okay, it remains just to understand that f0 should be 4, and this is the case. If we plug in of x0, we get that f0 equals to 4. Now let's pick the correct answer. For any a equals to 1, a equals to -1, there's no such a, and a equals to 3. And as derivative of this function is always 3 at point 0, and value of this function always is 4, tangent line is 3x plus 4 regardless what is the value of a. Always we have this case. Huh? Thereafter, how many of the following limits have an indeterminate form? Indeterminate, like this is indeterminate form, infinity divided by infinity. This is indeterminate form. It has 0 to the power of infinity. 0 to the power of infinity is another indeterminate form. This one is 0 times 0, which is not an indeterminate form. 0 times 0 is always 0. The next one is again infinity over infinity, which is fine. The last one is similar to the second one, infinity to the power of 0. Love, okay. Second and the last one. Are both of them indeterminate form, or
Երկրորդը 0 չի։
Երկրորդը 0, yeah.
Mm.
Why so? Because 1 over, you can treat as 1 over n to the power of n, or 0 multiplied with 0 infinity times, it makes it even more 0. Yeah, 0 to the power of infinity is 0, definitely. Hence, we get at the end only 3. The first one, infinity over infinity. Fourth one, infinity over infinity. And the last one, infinity to the power of 0. N to the power of 1 over n is an indeterminate form. Shorter. Okay, we are given a table where we have two missing cells. We have to understand or estimate f minus 1, f1. What is given? F is twice differentiable and f double derivative is positive. What can we say about these two missing values, or just one of them? Okay, how we can tackle this exercise? F double, the only thing that is given about f rather than contingent differentiability, which is not so useful in this table, that f double derivative is positive. So function is concave up. Concavity of function, we can think of second order derivative, but again, second order derivative is not useful when we have this work with tables. So we can think of the definition of concavity, which says that f alpha x plus 1 minus alpha y, concave up means value in between is smaller or equal than alpha times f of x plus 1 minus alpha f at y. So now to get this missing component, we can consider, for example, alpha is 1/2, x is -2, and y is 0. To get here, -1. So our goal is to make this argument to be -1. So f minus 1 is less or equal than f minus 2 plus f0 divided by 2. So here we get 2. Actually, since we have f double derivative is strictly positive, we can write that our f minus 1 is strictly less than 2. Okay, similarly, we can say that f1 is smaller than f0 plus f2 divided by 2. Why so? Because once again, concavity means f alpha. So all this stuff, when x we are choosing 0, y we are choosing 2. Okay, x we are choosing 0, y we are choosing 2. In between we have 1 point. Value of function at 1 is smaller or equal than this. Here we are not yet using the third, this row testing. So what is f1? It is 2. So f minus 1 should be less than 2. f1 also should be less than 2. Keeping this in our mind, what we can say. First of all, when we are saying that f is even function, we can eliminate from the beginning, because this table is not enough to say functions even. We don't know what's happening with function f in between -1, -1, -1, -1, or from 0 to 1. No enough information. f1 equals to f minus 1. Why should it be symmetric again? Who knows? This should be correct. Okay, f minus 1 less than 2. Yep, true. Why should it be positive and greater than 1? We can't eliminate from now this statement. We will come back it soon. What else we can do, guys? Do you have other suggestions, or should I move forward? What can we do to understand something about f minus 1 and f1? So far, we know that f minus 1 is less than 2 to get concavity.
Maybe
Okay.
we can watch their tangent lines.
Okay, our function is concave up, which means that if we construct tangent line at some point, tangent line should be below than our curve is located, right? So what is tangent line at point -1? Slope is given, right? -2 times x minus -1. And then we should add f at -1. And this slope itself should be smaller. But this is our tangent line, the tiny x. This should be smaller than our fx. Because we have concave up function. Concave up means that our curve is greater than function itself. Okay, from this inequality, what we can say, let's plug instead of x anything that is given here. For example, -2 or 0 or 2 to get some information that we can use. For example, if we plug instead of x, I don't know, -2, what we will get? If x equals to -2, what we can get? Plugging here -2, we'll get -2 times -1, f -1 is smaller than f -2 -1. Do you agree with this? So we plug instead of x -2 into this. F -1 is smaller than 3. Actually, it is not informative at all at this point. We had something better. Love. What if instead of -2 we plug here x is 0? What if instead of x 0, we'll get that f -1 is smaller than f0 is 0, is smaller than 2. Again, not an informative thing. We knew this beforehand. If we plug 2, we will get f -1 is smaller than f at 2 minus, if we plug once again x2, we'll get +6, something like this. And what am I missing? Maybe we should plug here x equals to interesting 1. The only thing that is missing here, 1. X equals to 1 plugged here gives f -1 is less than f1 +4. Okay, again, nothing, we have this in our list. So tangent line here is not super helpful. It could be super helpful if we decide to consider tangent line not at point. So here we took -1, tangent line at -1. Maybe we can take tangent line at, I don't know, 0 point or any other point. I don't know. Do you have other suggestions, guys?
Can we apply mean value theorem on -1 and 0, for example?
So if we apply mean value theorem here, mean value theorem will say that f -1 minus f0 divided by -1 equals to derivative in between. Let's try to write this down and see what do we know. Okay, f -1 minus f0 divided by -1 minus 0 minus 1. Maybe it is better to write f0 minus f minus 1. f0 minus f minus 1 divided by 1 equals to f prime at some point c. C belongs to 0 to -1 interval. Here is our c. Do you agree that f prime c is from 0 to 2? Because we know that f double derivative is positive, hence f derivative is increasing. Being increasing, so the value will be from -2 to 0. Which means we can say that like f -1 minus f -1 belongs to -2 to 0 interval. Which means if we multiply with -1, we will get this part is true. Now, if we try to use similar argument for this interval from 0 to 1. Let me erase all this stuff and write f1 minus f0 divided by 1 equals to f prime at c, where c belongs to 0, 1 interval. So this belongs to 0 to 2. Which means that since f0 equals to 0, f1 itself belongs to 0 to 2. Okay, what else we can say? Maybe we can apply mean value theorem on this part, which says f2 minus f1 divided by 1 belongs to 2 to 3 interval. Hence, minus f1 belongs, we should subtract from this interval f2, and f2 is 4. Let's subtract 4. We will get from -2 to -1. Hence, f at 1 belongs to 1 to 2 interval. So f1 is greater than 2. Here is our correct statement. f1 is from 1 to 2 means it is greater than 1. And f -1 belongs to 0 to 2 interval also was something correct. We just proved it again by mean value theorem. Another trick that we can apply to solve this exercise is again using definition for concavity, f alpha x plus 1 minus alpha y. But choosing like x and y, x is say -2, y is 2, and for which alpha x plus 1 minus alpha y will be -1, I don't know. We can try to find this alpha. So alpha times -2 plus 1 minus alpha times 2 equals to -1. Solve this and find alpha and use concavity definition for this specific alpha. And then apply definition for concavity. That also might be a useful step. But here we found the solution by applying mean value theorem. This exercise was tough. Questions? I saw a link. Oh, which questions? Let me go back. Gerekçiyor. İngilizce. 6th one. Given f prime equals to 0 for any x that belongs to 0 to 1 interval, which of the following statement is true? Okay, first of all, what do we know about functions which derivative is 0? We have the following theorem saying that if f prime equals to 0 on some interval, then function is 0 on that interval. We can say that f of x is some constant when x belongs to -infinity to 0. We can say f of x is maybe another constant as x belongs to 0 to 1 interval. And maybe fx is another constant as x belongs to 1 to plus infinity. So having derivative equals to 0 on interval, we can say function is constant. So here we have actually 3 intervals. X doesn't belong to 0. X is different from 0, 1. Means we have this interval, and the interval here. And on each of these 3 intervals, our function is constant, maybe different constants, but however constants. So keeping this in our mind, let's solve this exercise. Fx limit as x goes to 1 from left side. So we have, in this case, is 3. So C2 is 3. F minus 2 equals to 3. F minus 2 means we are here. C1 equals to 3. Can we say that from -infinity to 1, if I can make it think, this is, if we are discussing A, I jumped to B immediately. This means C2 equals to 3, but F4 being 4 means that C3 equals to 4. Can we say that function is 4 from 2 to 4 interval? F4 being 4 means our function is constant from 1 to plus infinity. Hence, fx is constant from 2 to 4 means, since this is true, since this is to be true, let's move forward. Maybe we can find, at this point, it seems that, yeah, this one seems to be okay. Testing harder. Limit from right side of our function is 3. So we are here, C3 equals to 3. F minus 2 equals to 3. So C1 equals to 3. Can we say our function from -infinity to 1 equals to 3? Nope. We don't know whether C2 equals to 3 or not. This is not given. So B we can eliminate. C says limit from left side is 3 at point 1, left side. So this is left side. This is 3. Okay. F2 equals to 3 means C3 also is 3. Can we say from minus infinity to whatever our function is C? No, at C3 is not given. So we don't know whether this is true or not. So we will say B is false, C is false. Here 3, here 3. So on first interval we have 3 because f minus 1, f minus 2 is 3. D inverted, yeah, here is 3. Can we say from minus infinity to 1? Our function is 3. Dine laat is eigenlijk. So f is constant from minus infinity to 0. If we say f minus 2 is 3, means this constant is 3. And at point 1, limit is 3. Hence, we can say function is here also 3. From minus infinity to 1, can we say our function is always 3? Nope. The only issue here is that this point, what is f0? We don't know what is f0. So no information about f0. Hence, we can drop this one. So before 0 and after 0, yeah, function is 3. But at 0 point, what's going on? We don't know. So let's drop D as well. It remains the last one. Fx here is 3. From 0 to 1 is 3. F2 equals to F5 equals to 3 means, okay, here function is 3. We don't know what's going on here. So we can say it is always 0. It remains A, which seems to be correct answer. And to get actually A is true, only this part was enough. F4 equal to 4 means starting from one function is always 4. Huh? Questions? If no question, let me move forward. Number 7, I'm going to skip this one. It is quite similar to the one that we considered a bit earlier. We can just take 3x into common. Okay, love. Let's do it quickly. When x goes to infinity, taking 3x into common, we'll get 3x times 1 minus x divided by 3x, taken all minus 1 over x power, which means we get 3 to the power of minus 1 power multiplied with 1 minus x over 3x to the power of 1 minus 1 over x. When x goes to plus infinity, what can we say about this part? When x goes to plus infinity, we get x over 3x going to 0. Hence, we get 1 to the power of 0. 1 to the power of 0 is a determinate form, it's 1. So we left 3 to the power minus 1, the only option. So this is the correct answer. Okay. Ksam aktivnače. And 7. Yeah, 7 down. Ksam activates Urishka multiple choice. 9 and 10, I see. Okay, 9 and 10. So we have given here f and capital F continuous, twice differentiable functions. We have to find what is f double prime sinus x equals. And here an integration by parts is done. Integration by parts formula says we have to write f prime x times sinus x minus integral of f prime times derivative of sinus x, which is cosine x dx. Okay. So we have to do another integration by parts. F prime x sinus x minus, so another integration by parts gives fx times cosine x, and minus when we are having derivative on cosine, which gives fx sinus x d of x, which is given to be capital F. This is capital F. So we have f prime sinus minus f cosine plus capital F. F prime sinus, sorry, minus f cosine. It seems this one. F prime sinus minus f cosine plus capital F. Yeah, the number E. So what we did to get this answer, we applied twice integration by parts. F double prime is derivative of f prime, and then just f prime is derivative of f. Questions? The next one. Given graph of the derivative of function f. We should find, this is graph of derivative. We have to find which of the following statement is true, and all statements are about monotonicity of our function. So let's just understand then that derivative of our function before 0 is positive, after 0 is negative. This is the only thing that we need from derivative to get monotonicity of our function. So f is increasing from minus infinity to 0 and decreasing from 0 to plus infinity. Can we say it is decreasing from -1 to 1? Nope. Increasing from -2 to 0? Yes. F has local minimum at 0? It's a maximum point, not minimum. F is not differentiable at 1. It is differentiable, and this is a derivative. F is not twice differentiable at 1, but just derivative of f exists. F has local minimum at 0.1. At 0.1 is here. On both sides of 0.1, derivative is negative, so 1 is not a critical point, so it's not an extrema point neither. So we have the correct answer, number B. Okay, and so we covered almost all multiple choice questions from 2021. It remains to see, do we have show work problem number 2? Okay, show work number 2. Do we need to do long division here?
Yes.
Yes. This is quite similar to our first example that we considered today, except here a long division step is required. So we have first to write this as, okay, to do long division, let me do it here. We have to divide x squared by, what do we have here? If we open brackets, we'll get x cubed. We will get, how many x squared do we have? 5. How many x's do we have? 4 plus 5, 9x, and plus 5. if we do long division, guys, we are going to get it's just 1 here. So 1 minus 5x squared plus 9x plus 5 divided by x plus 1 x squared plus 4x plus 5 dx. Just imagine we are adding to x squared, x cubed, 5x squared plus 9x plus 5, and we are subtracting the same term. So we left here this, meaning that we have to integrate 1 and this part. To integrate 5x squared plus 9x plus 5, we have to do decomposition step. So have written a over x plus 1, and then we'll get also bx plus c divided by x squared plus 4x plus 5 dx. This gives just x plus c, and this integral gives logarithm module x plus 1 times a. To calculate this integral after finding ABC, we have to complete square as before. Completing square, x plus 2 squared plus 1 will be nice if you get bx plus 2 here. Hence, we have to subtract 2b. Then splitting this integral into 2 parts as before will complete the exercise. Now, so let me move forward. Test 2021 done. Hajos taboranaink. Sign directive. Tasna innovative. Task innovative. Multiple choice number 1.
Կարո՞ղ մի հատ 16 թվի երրորդն էլ նայենք։
Գնանք։ Նա 19 թիվը նայենք, հետո 16 թիվ։ Okay. Find entire derivative of sine times cosine. Okay, 2 ways to find this entire derivative. One approach is just integrate sine x times cosine x dx. There are many ways to do this integration. Substitution might help here, or just writing this as 1/2 integral sinus 2x dx might help. Or another way of finding entire derivative, take derivatives of all these 5 functions, check which derivative gives sinus x times cosine x. So if we are thinking of calculating integral of sinus 2x gives minus cosine 2x divided by 4. And we have plus constancy. Do we have this given option? No, we don't. Right? We do not have minus cosine 2x over 4 plus c. So here some simplification, some modification of this is needed. What do we remember about cosine 2x? What is cosine 2x? In terms of cosine squared, how we can express cosine? Cosine squared x is 1 plus cosine 2x over 2. Am I right?
Yes.
So can we write cosine 2x is 2 times cosine squared minus 1? So here we'll get 1 minus cosine squared x divided by 4 plus constant C. I missed 2 times. Sorry, I have to fix like this. Do we have this answer given here? Let me modify to make it more visible. 1/4 minus cosine squared x over 2 plus constant C. Do we have here given function which is of this form for some value of C?
D when C is 3/4.
Yes, exactly. When we choose C in a way that 1/4 plus C gives 1, this is the correct answer. So this entire derivative. Also, by taking derivative of D, you will get sinus x times cosine x. Take derivative of this. Derivative of 1 is 0. Derivative of cosine squared with minus sign is going to be 2 times cosine times sinus. So exactly this. C is not working because derivative is going to be minus sinus cosine. C is not working. With the help of derivative, we can get. Let me see what do we have else from 2019. Multiple choice number 1. Multiple number 7. Okay. F prime equals to A. Then which of the following statement is true? So function f is differentiable function, which derivative equals to constant for any real number. Do you agree that f of x actually is a times x plus some constant, some b or some c? This is the only way to get function which derivative equals to constant a. Now, knowing that function f is linear function, if a equals to 0, can we say that function is 0? Nope, function is constant, not 0. A equals to 1. Can we say f3 minus f1 equals to 3? Let's check. When a equals to 1, our function is x plus b. So value to 3 is going to be 3 plus b minus value at 1 plus b. Is this 3? No. It is not 3, it is 2. So let's drop this one. If a equals to 1, f3 minus, and if we know that f3 minus f1 equals to 2, which is always the case, can we say that function fx equals to x? Nope. We have here b, and who says that b should be 0? f3 minus f1 equals to 2 is not guaranteeing that f3 minus f1 is, it's always 2. So I drop out, I think. If a equals to 2, f1 plus f minus 1 is 0. Can we say fx equals to 2x function? Let's check. So our function is 2x plus b. At 1, value is 2 plus b. At minus 1, the value is minus 2 plus b. And if we know that this is 0, actually this gives that b equals to 0. If b equals to 0, so fx equals to 2x. So yes, this is correct. And E is wrong because fx is, if a equals to 2, we have 2x plus b divided by x. And limit here is 1. Nope, limit always is 2 when x goes to plus infinity. So E is wrong as well. D is the correct answer. Last in the tabakan. Multiple 7, I think. multiple choice number 3 and show work number 3. Okay. Let's cover this. Given function f sinus x over ax minus x squared, for which parameter of a we have here essential discontinuity point at 0. Getting essential discontinuity we might have only because of this part, right? This one can give us essential discontinuity. Essential means limit is infinity or doesn't exist. So we do not have any control on 2 cosine x plus 1 through parameter a. So when x goes to 0, what can we say about limit x goes to 0 of sinus x divided by ax minus x squared? We can rewrite this as limit x goes to 0 sinus x over x times 1 divided by a minus x. So for which value of a 1 over a minus x at 0 goes to infinity if a equals to 0 to get 1 over x. So this one is the correct answer. Yep. We had a question again from this multiple choice number 6 from this test. Okay, find the limit here, and it seems we have here 1 to the power of infinity 4. To get the calculation done, we are going to use a useful limit of the number e. 1 plus 2 divided by n is the base. So let's create here n half term times 2 over n multiplied with n plus 1 factorial divided by n factorial plus 1. And consider limit of this part separately. So here we have 2 times. Let me write n plus 1 factorial as n plus 1 times n factorial divided by n times n factorial plus n. Could you say what is limit of this expression? Only this power. You are right. Just unmute yourself before saying the answer. The limit is 2. Hence, we get the limit of e to the power of 2. This is the correct answer. Also, show work number 3 from this year. Find limit. If we plug instead of x0, we'll get 0 over 0 indeterminate form. So I would suggest to rewrite this limit as limit x goes to 0. Having exponential 3x minus 1 on the numerator, we can apply useful limit, right? Will be nice if we have 3x divided by e to the power of 3x minus 1, which tends to 1. So we have multiplied with 3x, and let's divide by the same term. So x plus 1 times log 1 plus x minus sinus squared x divided by, so we have 3x squared left. Okay, we should calculate the limit of this expression. And to find limit of, let's do calculation of limit of this part. Here we have something that tends to 1. So maybe we can apply here L'Hopital rule. Let's do L'Hopital. We can simplify. We can. Okay, let's just rewrite like it's a 0/0. Hence, we can do L'Hopital. I'm skipping all details. We'll get limit x. I'm just calculating the limit of this part. I must not make x goes to 0. So derivative of numerator. Derivative of x plus 1 is 1. So we left just log 1 plus x. Derivative of log 1 plus x is 1/1 plus x. So times x plus 1, we get 1. Minus 1. Minus derivative of sine squared x gives 2 times sinus x times cosine x. And we are dividing this by 6x. Okay. No need to do L'Hopital anymore. We get limit x goes to 0. Log 1 plus x divided by 6x and minus sinus 2x divided by 6x. Here we have a useful limit going to 1, and this goes to 1/3. Limit is 1/6 minus 1/3. Minus 1/6. Going back, we'll get that limit here is minus 1/6. And we have questions here, guys. Going back to the second one. Okay. The numerator is third order polynomial. And we know that it has definitely at least one real root. We have to factorize this term. How we can factorize here? We can, from the first two term, or we can plug constant like 1 minus 1, and immediately minus 1 will work. At minus 1 it is 0. So it is going to be divisible by x plus 1. We can write x squared x plus 1 plus x plus 1 our denominator, and immediately we will get 6x squared plus 3x plus 1 divided by x plus 1 multiplied with x squared plus 1. So integral a over x plus 1 plus bx plus c divided by x squared plus 1. And no need to do complete square step here because it's already x squared plus 1. Just we will get integral of bx over x squared plus 1 and integral c divided x squared plus 1. C multiplied with arctangent and b multiplied with log x squared plus 1/2. Enough? Okay. I think we are done with this year. So 2019 completed. Միջև ասիկ 16 թիվ, չէ՞, ոնց է 16 թիվներ։ Մտահոգում։ We have a question, show work number 1 and 3 from 2024. I'm not sure that we have enough time to cover it today. Տեսնենք, եթե վերջում ժամանակ մնաց կանենք, because we have already tested, so կարող ստացվի։ 19 Գեցինք 16։ Okay, բայց որոնք են 16-ից։ 2016. Show work number 2, multiple choice number 3. Multiple choice 2, 3, 5. Okay, 2, 3, 5, and couple of show works. We have this multiple choice saying f prime is less than, with module is less than 3, find here correct statement. And it looks like mean value theorem is needed here to be applied. If we think of first statement, fx squared minus fy squared divided by x squared minus y squared is going to be f prime at some point c. So if we put module here, it's less or equal than 3. We need to get here 3 to say that statement A is correct. Without 3, statement A is wrong. Statement B is a bit different because, first of all, here we have x minus y, not x squared minus y squared, and we have 12 factor. So, keeping the same left-hand side, we can say module fx squared, let's multiply by x squared minus y squared. We can get fy squared is less than 3 times x squared minus y squared. We do not have this answer among all these 5. Here we can modify a bit by writing x minus y times x plus y, and x minus y term is present here. What can we say about x plus y? If x belongs to xy are from -3 to 3, we can say x plus y with module, we can estimate with 6. Hence, 6 times this is smaller or equal than 18 x plus y, x minus y, sorry. 18, not 12. With 12, again, it seems statement is wrong. For C, we have f squared. F squared mean value theorem. We need to get derivative of f squared. We can postpone this. I don't know whether this is, it seems to be strange. We will come back to C is true if derivative of f squared. So we can justify C is true if and only if derivative of f squared is bounded by 1, f2 prime. Is it smaller than 1? No, it's 2 times. So f times f prime, not enough information about this. Most probably this is wrong. What about D and E? Again, mean value theorem needed. 2x plus 1 minus 12. So f 2x plus 1 minus f 2y minus 1 divided by the difference of arguments. So 2x plus 1 minus 2y minus 1 with module is smaller or equal than 3. Hence, D is true. It's mean value theorem. And E is wrong because of this sign. Come on, it should be smaller, not greater. So we have the correct answer, number 2. Three and 5. Okay, the next one, f of x is greater than f0 plus 3x. Okay, so we can treat this exercise different ways. Maybe again mean value theorem, maybe definition of the limit. So f prime equals to 3 means that limit f of x minus f0 divided by x as x goes to 0 equals to 3. We have given this limit. Statement A says fx, bring f0 to the left side, divide by x. We can divide by x because x is from 0 to delta, delta is positive. Can we say that fx minus f0 over x tends to 3 being greater than 3? No, we don't know this because maybe our fx minus f0 divided by x tends to 3 being smaller than 3. Maybe it tends to 3 from left side, not from right side. So A is wrong, and similarly, E is wrong. If we do the same for E, we can get that it is not. So E says, actually, if we bring f0 to the left side and we divide by x, if we divide by x, where x is negative, we have to change the sign. Can we say fx minus f0 over x is smaller than 3? Again, we don't know. It could be greater than 3. It could be smaller than 3. It can oscillate. So A and E are eliminated. Now, B and D, let's treat B and D together. Fx, bring f0 to the right left side, divide by x. Is this smaller than 2? No, it tends to 3. It can't be smaller than 2. It tends to 3, so limit. This is wrong. What about D? If we divide by x, and knowing that delta, we have now x negative. If x is negative, this is greater than 2. And this is true because if we have some function that tends to 3, starting from some moment, it is going to be greater than 2. Hence, this is true. What says C? C says fx. Here we have strangely 2 appearing. Fx minus f0 divided by x. Okay, let's for example, imagine we have f0 equals to 0. There is no anything against this statement. If f0 equals to 0, C can't be true. That can't be true. F0 but sorry. Yeah. Fx being greater than x. So for C, we do not have any reason to believe it is true. Fx minus f0 divided by x tends to 3. If we move one f0 to the left side and we divide by 3, we get here it's greater than f0 divided by x. No. Or imagine we are passing to the limit when x goes to 0. Here, x goes to 0. If we pass to the limit, f0 will be greater than 2 times f0. Of course not. So this remains the only correct answer. Okay, Yerek and 5.
Thank you.
You have a question?
No, thank you.
2, 3, and 5. So given a big table, and here we have values for f, g, f prime, g prime. Points are given from 0 to 5. We should find critical points for the composition of f with g. Okay, to find which points are critical points, derivative of the composition gives f prime gx times g prime x. So to be critical point, we might think of g prime x being 0. Hence, this is a critical point for sure. 2 is a critical point. Then also f prime gx equals to 0 will give us what? F prime equals to 0, hence gx equals to 3. Gx being 3 also will give us critical points. Gx equals to 3 means this 2 points, 3 and 3. 0 to 5. Hope we have such answer. Yes, we do. Questions? Okay, guys, do you have any question that actually it's still open for you? So we have plenty of questions yet. Put it on chat. I am sorry, I do not have time to cover all questions. So maybe if you can just give me a couple of questions that actually is still open, we can tackle them. If no, actually tomorrow you are going to have extra PSS session. At least as far as I know, Lucine is going to run one PSS session. You can bring your questions for this session.
Sıra show work երեքը կարանք անենք։
İyi come. Okay. We have cotangent x times logarithm 1 plus 3x minus 2x. And our goal is to find limit. Let's think of limits of each of these components. When x goes to 0, what is limit of this part? We get logarithm 1 minus 0, so it tends to 0. X goes to 0. What about cotangent at 0? Cotangent at 0 is infinity. So we have infinity times 0 form. We can rewrite this as, so what is actually cotangent? Cotangent is cosine over sinus. Let's write it as cosine cubed x times x times logarithm 1 plus 2x minus 2x divided by sinus cubed x. We are going to divide by sinus cubed. I would suggest to have here x cubed divided by sinus cubed x. So we wrote sinus cubed, but I have multiplied x cubed. So we have to divide by x cubed also. Now, to do the calculation, I would suggest to focus only on the following part. Logarithm 1 plus 2x minus 2x divided by x squared. If we find the limit, then we can complete the puzzle by putting all values together. Okay, how we can find this limit? Let's do not invent something very smart, just apply L'Hopital rule, because here we have 0 over 0. L'Hopital applied here gives x goes to 0. Therefore, logarithm 2 over 1 plus 2x minus 2 divided by 2x. If we plug 0, we'll get again 0 over 0. Modify a bit, limit x goes to 0. If we bring into common denominator, we will get 2 minus, so we'll get minus 4x divided by 2x times 1 plus 2x. I just brought into common denominator. So here, just dropping x from numerator to denominator and plugging x equals to 0, we will get this limit is minus 2 going back. Cosine squared goes to 1. This part goes to 1, and here x cancel with x cubed. We get limit equals to minus 2. So I think, yeah, we found it.
Ունեք մի հատ հարց տամ, էլի, ես սրա վերաբերյալ։
Please.
Եթե մենք այդ կոսինուսը դուրս հանեցինք, հետո այն մնացած մասում, որ useful-ներ օգտագործեինք, Ոչ թե բանա
Կլիներ։
մենք okay լրիվ։
Հա, that is fine. Like
Այսինքն եթե այդ կոսմոսը դուրս ենք հանում ինքը ձգտում է 1-ի, այդ մեզ ընդհանրապես չի խանգարում մնացածում useful
ignore
օգտագործել։
Ignore cosine term because it's not going to hurt. It's just something that tends to 1.
Okay, merci շատ։
Okay. Love, George, եկեք sense. Let's continue discussion. I have okay on Friday. Love? I'm kidding. If you have like questions that you can't find answer, please drop me an email or tomorrow come to my office. You can discuss questions. Meanwhile, you have a PSS. You can attend PSS sessions scheduled for tomorrow. Because we are here already more than 2 hours. I think you are tired a bit, not me. Okay, guys, thank you. Good luck with remaining finals and see you on Wednesday.
Thank you.
Thank you.
Bye-bye.
Bye.
Thank you.